Hello and welcome back. So today I'm going to discuss on design process. Well, we have completed the models which we are using for designing. So we will see how the design process is to be carried out. So software design is an iterative process through which we can like requirements are translated into a blueprint for constructing the software. That is, design is represented at a high level of abstraction. That is, a level that can be directly traced to the specific system objective, more detailed data, functional and behavioral requirements. So there must be three characteristics that serve as a guide for the evaluation of a good design, and they are: the design must implement all of the explicit requirements contained in the requirements model, and it must accommodate all of the implicit requirements desired by the stakeholders. So both explicit and implicit requirements are taken into account while implementing design process. Next one is the design must be readable, understandable guide for those who generate code and for those who test and subsequently support the software. And the design should provide a complete picture of the software, addressing the data, functional and behavioral domains from an implementation perspective. So in short, we should design a process must be designed in order to implement it very well. Okay. The next is quality guidelines. So in order to evaluate the quality of a design representation, software team must establish technical criteria for good design. So the guidelines considered here are: a design should exhibit an architecture that has been created using recognizable architectural styles or some patterns, and is composed of components that exhibit good design characteristics, and it must be implemented in an evolutionary fashion also. Okay. And design should be modular, that is, the software should be logically partitioned into elements or subsystems. That means we have to divide the software into modules. Now, a design should contain distinct representations of data, architecture, interfaces, and components. A design should lead to data structures that are appropriate for the classes to be implemented and are drawn from recognizable data patterns. A design should lead to components that exhibit independent functional characteristics. So a design should lead to interfaces that reduce the complexity of connections between components with the external environment also. A design should be derived using a repeatable method that is driven by information obtained during software requirement analysis. A design should be represented using a notation that effectively communicates its meaning. So these are the quality guidelines that are to be followed while designing a software. Now we have some quality attributes also. So the FURPS quality attributes represent a target for all software design. FURPS means functionality, usability, reliability, performance, and supportability. It is an acronym for all these points. So first we'll see what is functionality. So functionality here is assessed by evaluating the feature set and capabilities of the program, the generality of the functions that are delivered, and the security of the overall system. That basically it should function properly. That is known as functionality. Our next attribute is usability, which is assessed by considering human factors. The like overall aesthetics, consistency, and documentation. Okay. Then we have the third one, that is reliability, which is evaluated by measuring the frequency and severity of failure and the accuracy of output results, the mean time of failure, the ability to recover from the failure, and predictability of the program. So always the software need to be predictable that what happens next. Like now, a fourth one is performance, which is measured by considering processing speed, response time, resource consumption, throughput, efficiency, etc., etc. Then supportability, combines the ability to extend the program, adaptability, serviceability, like all these things. We can, in short, we can say that the software should be maintainable. It should process maintainability. Along with that, testability, compatibility, configurability, and the ease with which we can install the system, the ease with which we can recover the system. All these factors comes under supportability. So these are the quality attributes which are to be considered. Our next topic is design concepts. So we have known what is a design process. Now we'll see what is a design concept. What all concepts comes under designing a software project. So the first concept which comes is abstraction. So when solving a problem in modular way, we already said that we have to divide the problem into modules, right, before designing. So when solving a problem in modular way, many levels of abstractions can be implemented. We can say that at the highest level of abstraction, a solution stated in broad terms using the language of problem environment. And at lower levels of abstraction, a more detailed description of the solution is provided. That is, it can be stated in a manner that can be directly implemented. Okay, we can directly implement to the solution of the system. So here we can say that we have provided two abstraction levels here. That is, one is procedural abstraction, which refers to a sequence of instructions that have a specific and limited function. So we can say the name of a procedural abstraction implies these functions, but specific details are being suppressed. So here we can consider an example, the example would be the word open. Okay, open for a door. So open is the word which describes procedural abstraction. So open implies a very long sequence of procedural steps. That is, we have to walk to the door, reach out and grasp the knob of the door, then turn the knob and pull the door. Then after that we have to step away from the moving door, etc. So all these are the procedural abstractions or instructions that have to be given while opening a door, or procedural abstraction of the word open. Our next category is data abstraction, which is a named collection of data that describes a data object. So here, in the context of the procedural abstraction open, we can define a data abstraction called door. So we can say that a door would encompass a set of attributes that describe the door. That is what type of a door we use, then its swing direction, then the opening mechanism of the door, then the weight, dimension, etc., which all data that describe the word or data abstraction that we can give to the word door. So all these abstractions are connected to each other. Our next design concept is architecture. So architecture is the structure or organization of program components or modules in which these modules interact, and the structure of data are used by the components. So we will see how these modules are being organized and how these modules interact with each other in order to receive and send data accordingly. So we have some points. That is, we can define a set of properties that should be specified as part of an architectural design. So the first property is the structural properties. It defines the components of a system. Components means that is the modules, objects, filters, etc. Whatever we can use to define a component, and defines the components of a system and the manner in which these components are packaged and interact with one another. All these are being specified in the structural properties. Then we have the next property, that is extra functional properties. It should address how the design architecture achieves requirements for performance, capacity, reliability, security, adaptability, all the factors how we can maintain the software. Okay. And the third property is families of related system. So here the architecture should draw upon repeatable patterns that are commonly encountered in the design of families in similar system. That is, in short, we can say that whatever designs we are implementing, it should be reused or it can be reused. That is known as families of related system. So we have so far discussed two concepts regarding designing, that is abstraction and architecture. We have further more concepts which we will be discussing in the next episode. Hope you all have understood today's episode. So for the same architecture, by specifying these properties, we can represent all these architecture by a number of different models which we have already seen. First one is the structural model, which represents architecture as an organized collection of program components. Then we have framework models, which increase the level of design abstraction by attempting to identify repeatable architectural design frameworks that are encountered in similar types of applications. All these we have seen. Then we have the dynamic models that address the behavioral aspects of the program in architecture, indicating how the structure or system configuration may change as a function of external events. Then we have process models, which focus on the design of the business or technical process that the system must accommodate. And we have functional models, which can be used to represent the functional hierarchy of a system. So we can use specified models regarding the architecture when we know all the properties. And when we know all the properties and we know again all the models, then we can use specific languages which is related to design the system. So all these are about design concepts. We have further more design concepts to discuss, which I'll be discussing in the next episode. Thank you so much.